So you continue and say this. You continue and say this. Calculus is divided into two areas. Calculus is divided into two areas. It's divided into two areas. We have got two branches of calculus. The first one, A, it is what we call the differential. The differential calculus, commonly known as differentiation. The differential calculus, commonly known as differentiation. And then B, we have the integral. Integral calculus, commonly known as integration. Commonly known as integration. Let us start with the first one, differential calculus. Let us start with the first one, which is the differential calculus or differentiation. Differential calculus or differentiation. You record that it is the study of the rate of change. It is the study of the rate of change at a point. The study of the rate of change at a point. The study of the rate of change at a point. Then you say, it is the process of finding, it is the process of finding a derivative. The process of finding a derivative of a function. Of a function which is the same as equation. The process of finding a derivative of a function or equation. Then you say that a derivative of a function, is the gradient function. The derivative of the function is the gradient function. The derivative of the function is the gradient. Is the gradient function. It is the gradient function. It is denoted by dy over dx. It is normally denoted by dy over dx. Then you say that the derivative is obtained. The derivative is obtained by the following general rule. The derivative is obtained by the following general rule. By the following general rule. If we have y is equal to x power n, we have y is equal to x power n, the derivative, which is dy over dx, will be equal to n x power n minus 1. N x power n minus 1. The key thing I want you to note, don't be disturbed by this, it is that this power will multiply the number that will be in front here, n times the number that we have here, and then the power will be reduced by 1. The power will be reduced by 1. Examples. Here we say find the derivatives. Find the derivatives into bracket gradient functions into bracket gradient functions of the following expressions So if you are trying to find the derivative in simple terms, we are getting the gradient function, and that gradient function is actually obtained by dy over dx. So A, you are given y is equals to maybe x power 4. Y is x power 4. If you are given this is the equation of a function, then you are told to get the derivative, which is now dy over dx. It will be given by this 4. Remember here there is 1 x power 4. There is one that we normally don't like because it has no effect. 1 times x power 4 is the same as x power 4. So there is not hidden 1 here that is there. We multiply it by 4. 1 times 4 is going to be 4 x, and then the power of x will be reduced by 1. So it is going to be 4 minus 1, which is the same as 4x power 3. And that is the answer. This is the answer. 4x power 3. So this 4 will multiply the number that is there, and the 4 is going to reduce by 1 to be 3. Let us talk about B, where you are given y is equals to 6x power 3. Y is equals to 6x power 3. For you to be able to get the derivative, you are getting actually the dy over dx, which is given by what? 3 will multiply this 6 to be 18 x. The power of x, which is 3, we reduce it by 1. Now it is going to be power 2. So 3 multiplies 6 to be 18, and then that power of x, which is 3, we minus 1 from it to get the power to be 2. So if we have example C, which says that y is equals to 5x power 3 plus 2x power 2, like that. How do you get the derivative, which is dy over dx? You differentiate each function separately. So what you do, you differentiate this part first, 5x power 3. 3 will multiply 5 to be 15x, and then the power of x, which is 3, will reduce by 1 to be 2, plus 2 will multiply this 2 to be 4x, and then the power of 2 will reduce by 1 to be power 1, And in normal cases, we don't put power 1. Any number raised to power 1 is just the same number. Right? So x power 1 is the same as x, like that. X power 1 is the same as x. Then if when we have y is equals to 4x power 4 minus 3x power 3 plus 5, or let me now put here minus 5x power 2 plus 8x minus 9. What is your dy over dx? The principle or the rule will actually apply, but it's going to apply in each part separately. Yeah? We differentiate each and every section separately. So here we start by differentiating differentiating 4x power 4. The rule is the power to multiply the number that is ahead of x. So 4 times 4 is going to be 16, and then the power will reduce by 1 to be x power 3. Minus, also that minus, this power to multiply this 3 so that we have 9 x power 2. This 2 will multiply this 5 so that we have minus 10 x power 1, which is x. Remember here, there is 1. Remember when we have anything like 10x, it is actually power 1. Only that we don't indicate that 1 because it has no effect. So there is power 1 that is not indicated. 1 times 8 is actually going to be 8. And then this power 1 with minus 1, 1 minus 1 is 0. So we are going to have x raised to power 0 here. And at that point, I need to explain something here. Any number that is raised to power 0, the answer is 1. Any number in this one, or any letter that is raised to power 0, the answer is 1. Even if you try with your calculator, raise any number to power 0, the answer is 1. So x power 0, it is equal to 1. 1 times 8 is 8. So at the end of the day, because of x power 0 is 1, and 1 times 8 is 8, we can simply have it as 8. And then we minus. Whenever we have a constant, in this case 9 is a constant because it does not have any x attached to it. Whenever we have a constant, if you differentiate a constant, the answer is 0. Reason being, this is the same as 9x raised to power 0. Remember, we said that we had x raised to power 0 here, which we said it is 1. And therefore 1 times 8 is simply 8. The same case, when you have 9, there is an assumption we make that there is x raised to power 0 that is supposed to be multiplied here. And because of that concept, 0, that is power 0 times 9, everything will be 0. Everything will be 0. Note this, anytime you differentiate a constant, that constant will turn to be 0. Why? Because that constant, it is attached to x power 0, or it is a coefficient of x power 0, and that power 0 will multiply by that constant to make everything to be 0. So here we are going to have 0. So don't trouble yourself. Anytime you find that there is a constant, even if it is 1,000 without any x, then just know that if you differentiate it, it becomes 0. If you differentiate a number that has got x power 1 or a coefficient of x power 1, if you differentiate that, x disappears. You just remain with the number. X disappears like that. Alright. The process continues. Just a minute, I will adjust my camera upwards. I want you to try this and then give me the answer. Or we shall do it together. Here, E is y is equal to negative 6x power 4 minus 8x power 3 plus 9x squared plus 5x minus 11. I want you to get the derivative, which is dy over dx. Tuanze. Nancy, give me the answer for the first part here. negative 6x raised to power 4.
Okay, 24x.
24x raised to power. And also note that 24 will be negative because it is negative 6 here. Are you done in answering?
Just a minute, I lost you at some point. What did you say?
Okay, I'm saying you differentiate from
Yes.
negative 6x power 4.
Okay, equal to negative 24x.
It's going to be negative 24x raised to power
Power 3. Sorry, power 3, yes.
That is correct. Negative 24x raised to power 3. Always the power will reduce by 1.
Yes.
Minus Imelda.
Yes.
Give it a trial. I want you to differentiate this 8x power 3.
Okay. It's 24 x squared.
Exactly. Plus Ruth. Is Ruth with us? You just unmute your mic. Unmute your mic first. And now you can speak up.
Sorry?
How are you? You're well?
Yeah.
Have you said something, Ruth?
Tell me.
We are 9x squared.
No.
Maybe to be assisted by Faith. Faith, assist here.
18x.
Yes, we are going to have 18x. Then lastly we have plus. Is Mike around? Mike is not there. Wycliffe, 5x will come.
It will become 5.
It becomes 5. Remember we said when it is power 1, this x will be power 0. Yeah? And then when you differentiate a constant, everything comes to be 0. So we stop there. We stop there. Because we say attached to 11 is x raised to power 0, and that 0 multiplied by 11 will make everything to be 0 on that side. So we stop there. And this is actually a derivative of that. F, when you have y is equals to 12x maybe cube minus 7x squared plus 9x plus 13. What is our dy over dx? We start with the Catherine. You just do the first one. Only 12x cube will be differentiated to be
36x squared.
Yes, 36x squared is correct. Emily, 7x squared will be differentiated to be
14x.
Sorry, Emily.
14x.
I've not heard you.
14x.
14x. Yes, that is correct. Plus Stacy. 9x, if you differentiate it, it becomes if this test is not with us, we can okay. If we differentiate to 13, what will happen? Faith. Faith.
It should be 0.
It will be 0. It will be 0. We stop actually. So, but this one we are not differentiating.
What of 9? Yeah,
Then
yeah, 9.
now will be 0 like that. So that is how we do differentiation. The power multiplies the number you want and all that. But maybe we can do the last one, which is 8. What about if we are going to differentiate y is equals to 1 over 3x cubed plus 4x squared minus 10x. Let me not put 10x. Just put it a bit different. 10 of x minus maybe 8. That is the equation that has been presented to you, and you are told you integrate that. You get your dy over dx. The same concept applies. 3, it is supposed to multiply Adad, 3 times Adad. Remember when we have 3 times Adad, 3 and 3 will cancel out, so we shall only remain with x power 2. We shall remain x power 2 plus, this one is in simple, 8x power 1. Now, when we have it as 10 over x, there is a rule that I need to remind you. I know it has been time since you left high school for some of you, but when we have a number like 1 over x, when you have a number like 1 over x, you need to know that this is the same as x power 1, power negative 1. When it is 1 over x, it's the same as x power negative 1. When it is 1 over x squared, when it is 1 over x squared, this is the same as x raised to power negative 2. Actually, x or the numerator disappears, but now x or the power, it is now going to be negative. 1 over the one that disappears will remain with x, but power negative 2. So when we have, we continue giving more examples of this before we work out that. When we have 2 over x, this is the same as 2x power negative 1. When we have got 3 over x squared, this is exactly the same as 3x power negative 2. So x will go up, but its power will be negative. Its power will be negative. So allow me to first of all write this here. This one, so that I change this part. So this is the same as y equal to 1 over 3x2 plus 4x power 2 minus 10x. Remember it was x power 1. So it is going to be 10x power negative 1 minus 8. So it can be written as this. This x power 1 will go up now to the x power negative 1, and then you can now apply the rule of differentiation to find your dy over dx, which will be Just a minute, sorry. So we can move on now. We said 3 times a done, 3 and the 3 will cancel so that we remain x, but the power will reduce by 1. So it is going to be x power 2 plus 2 times 4 is 8, x power 1 minus this negative and this negative here. Actually, we change this one to be plus. Remember, this is negative 10. X power negative 1. This negative and this negative will change this one to be plus 10x. What about now the power? Remember, the power will be, it is negative 1, then we minus 1. Negative 1 minus 1 is the same as minus 2. So it is 10x power negative 2 minus 0. Minus 0. This is x power 0. That is 0 times this 8. Everything becomes 0 as we say. When you differentiate a constant, everything comes to the 0. So that is actually going to be your answer. Or you can go ahead and write it like this. It can be equal to x squared plus 8x plus 10 over x power 2. You can also check it and write it like that. It does not have any effect. But remember, when this power or this x goes up, its power becomes negative. When it goes down, its power becomes positive. So those are the basic rules that you need to understand as far as differentiation is concerned. At this moment, I will maybe give room for you to ask me some questions or clarification on areas you feel like you have some doubts or you are not very okay with, or you feel I did not explain well.
I have a question.
Yes.
So this 10x power minus 2, you cannot multiply minus 2 times 10.
You cannot
Multiply minus 2
by 10.
by 10.
No, you cannot do that because it was minus 1. When we multiplied minus 1 times this one, that is where we got this. So this one, it is a derivative of this. Already it has been differentiated. Already it has been differentiated. We had this, we differentiated to get this. So you cannot differentiate again. If you multiply this, now you are doing what we call the second derivative, and it is not the right thing. So I think you need to understand that this negative 2 came as a result of differentiating this part. This negative and this negative made it to be positive. 1 times 10 is 10, and then minus 1 minus another 1, we get minus 2. So as we did the others, we got this. So this is a derivative of this. Is it okay?
Okay. Okay.
Yes.
Okay, may I ask?
Yes.
Would you please give us 1 or 2 more examples of that last, the last question?
This one, eh? Okay, no problem.
Yes.
That last example, let me adjust my camera and then we'll do that last example. This is example G. Just my mic up.
It is example H.
Y is equals to maybe 1 over 4x power 4 plus 3x over x power negative 3 or power 3, sorry, x power 3 plus 3, not 3, actually this is 3. Let me write this function again. Plus 3 over x power 3 minus 8 over x squared. You are given that. One thing you need to note, whenever there is something like a fraction, you take it upwards, but the power becomes negative. You take this x power 2 upwards, but the power becomes negative. So this function can be written as y is equal to 1 over 4 x power 4 plus 3 x power negative 3. This x power 3 goes up to the x power negative 3 minus 8 x power negative 2. That's it. I'm just now, this is not differentiation, I'm just writing this equation in another form. It is the same equation but written in another way. Now that we have this, we can now get the derivative, which is dy over dx, which will be given by 4 times a quarter, 4 times a quarter, 4 and 4 will cancel, so we shall remain with x power 3. Remember, always the power must be reduced by 1. This negative 3 times positive 3 will give us negative 9x. What about the power? Remember, we had a negative 3, then we minus 1. You find that this is the same as what? Negative 4. Negative and negative will be positive. 2 and 8 is 16x. And then now the power that we had is negative 2 minus 1, because it is a rule. You find that now it's going to be minus 3. So this is actually the derivative. Or it can be written as dy over dx is equals to x power 3 minus 9 over x power 4. You can take this one downwards to be the denominator, but its power now will be positive, plus 16 over x power 3. You can also write your answer this way or that way, but you still get the answer as correct. So you note when x is below, it is positive. When it goes up, it becomes negative. When you bring it down again, it becomes positive, like that. So that is the very small concept that you need to understand. Whenever the functions are represented in the form of fractions like this, you change it into this form for you to be able to easily find the derivative like that. I hope now it's okay.
Mr. Makori, this is what I was asking you, eh?
Yes.
Because initially I was asking you if okay, I get it. The first equation you showed us 10 power minus 1. Did you multiply 10 by minus 1, which is
Yes.
of course 10?
Yes, I multiplied this 10 by negative 1. Let me try to form it. You multiplied. Actually, you are talking about this?
Yes.
Yes, I did multiply because negative 1 times negative 10, that's where we got positive 10. This negative 1 and this negative 10, and remember, 1 does not have any effect with the 10, 10 will remain. But this negative and this negative, if you change this one to be And then now, because we had -1, then there is -1 what we had minus another one because the rule requires that every power we must base 1. So -1 minus 1, that's where we go to -2. Are we together, Catherine?
Yes.
So I actually multiplied these. If you differentiate this,
So when you multiplied, it still became a -2 down there. The second part you circled, it still became 10x minus power -2.
yeah, here when it is upwards, this is power -2. But when we write it this way now, x will be +2.
Okay.
The same
Okay,
case
okay.
we have done here. The same case we have done here. Let me adjust my camera a bit. When it is like this, it is power negative. But when we put over, the power becomes positive. When it is 16x, it is power -3. But when we put 16 over, x becomes +3. The same case applies here. The same case applies here. When it is 10x, when we don't have over, it is power -2. But when we come here, we put it to be over x power +2. Are you now okay?
So I have a question, Mr. Nkuri.
Yes? Or I'm not answering
I'm
you?
fine. I'm okay.
You're okay?
Sorry, so I have a question.
Yes.
So in an exam,
Yes.
we can choose to differentiate using either of the two methods. The answer will be correct. So whichever method we feel is comfortable, we can use out of the two.
Allow me to respond it this way. We don't have two methods. It is only one way of differentiating. The only difference is where you leave your answer. You can leave your answer at that point, which is correct. You can choose to go further and leave your answer at this point, which is also correct. But the idea of differentiation is one. You have your equation, then the power multiplies the number ahead of x, you get that. The power reduces by 1, you get that. This one. But now, after getting this one as 10x power -2, you can show the examiner that you know mathematics. Tell the examiner that this 10x x power -2, it is the same as now 10 over x power +2. So it is where you leave your answer, but differentiation does not have two approaches. It has only one approach, but you can leave it here or leave it here, your answer, which is still the same. So.
Okay. Yes, thank you.
That is how we find the derivative. But don't be disturbed so much with this negative. Remember, we are doing introduction to calculus. Don't forget that ours is introduction to calculus. More often, you will be given equations that are simplified, like these ones. More often, but we need to go a step ahead so that we can see if it is given like that. How do we go about it? So that is how we do differentiation. Having done that, we can have a very small discussion about second derivatives. Just write second derivatives. How do we get the second derivatives? Second derivatives. Second derivatives. Second derivatives. So you say this, a second derivative is obtained, the second derivative is obtained, the second derivative is obtained when a function is differentiated, is obtained when a function is differentiated twice, is obtained when a function is differentiated twice. Differentiated twice. It is normally represented as, d y squared over d squared x. It is normally represented as dy squared over d squared x. So a second derivative is obtained when we differentiate a function twice. So we differentiate the first time. When we differentiate the first time, we get dy over dx. And the dy over dx that we get, we differentiate again. We differentiate again to get now the second derivative, which is dy squared over dx squared. E.g., examples, just say examples. Find the second derivatives. Find the second derivatives from the following. Functions. Find the second derivatives from the following functions. Find the second derivatives from the following functions. So allow me to adjust this camera upwards. And I want to use this equation. This equation, we find the second derivative. So in your A, we just write, we have got y is equals to negative 6x power 4 minus 8x power 3 plus 9x squared plus 5x plus 5. That is the equation or the function, and you are told from it we determine its second derivative. So the first thing you do is to get the first derivative, which is dy over dx, the normal way we have done it. So you shall get 4 times negative 6 is negative 24 x power 3 minus 8 times negative 8 will be negative 24 x squared plus 2 times 9, which is 18x plus 1. That is the first derivative. After getting the first derivative, we go to the second derivative now, which is dy squared over d squared x. It's going to be equal to, you differentiate now the first derivative again. So you get 3 times 24, which is what? 72. Negative 72x squared. The power must reduce by 1 step. Minus 2 times 24 is 48 x plus 18. That is your second derivative. That is your second derivative. So the second derivative, first of all, you get the first derivative, which is dy over dx. Then after getting the first derivative, which is here, you differentiate that first derivative to get the second derivative. So sometimes you can be asked in a question, find the second derivative of the following functions. The second derivative is simply differentiating the function twice. Differentiate the first one to get the first derivative, then you differentiate the first derivative to get the second derivative. That is A, B. Let us see how we get the second derivative of the following.
Manu, where did the 18 come from?
Sorry? 18.
The 18 number.
Yeah.
Oh, okay.
You
That
know,
one.
18x power 1. Eh? 1,
Yes.
18 is 18. And then because it is power 1, 1 minus 1 is 0. You remember that? And any number raised to power 0 is 1. So this is like 18 times 1, and 1 times 18 is just 18. The key thing you need, the power keeps on reducing. This one was power 3, it becomes power 2. This was power 2, it becomes power 1. This was power 1, it becomes power 0. But note that power 0 is the same as 1, and the 1 times the number that we have there is just that number. The powers keep reducing. So if you have got y is equals to 9x power 4 plus 3x power 3 minus 8x squared plus 14x minus 6. You are told you find the second derivative. So Stacy, I can see your hand is up. Say something.
Oh, I'm trying to say,
Yes.
you see on the 18x plus 5,
Yes.
where did the 5 go to?
5 disappears miraculously. Yeah? But anyway, this is the point. The 5, remember, the 5 was, or I said is, whenever it is a number that is not attached to x, there is x power 0 that is not written. Just know that any number that does not have x, it is actually having x raised to power 0. And actually, because we know x raised to power 0 is 1, any number raised to power 0 is 1. So that x power 0 was not indicated there. This one big, x raised to power 0 is 1, and 1 times 5 is simply 5. So it is not written. But if it is there, that when you are differentiating, you need to know that it is there. If it is there, x raised to power 0, 0 times 5 will make everything to be what? 0. 0 times 5 is 0. 0 times that 1 is just 0. Yeah? So, because of that concept that there is x raised to power 0 there, if you differentiate 5x raised to power 0, that power 0 will make everything to be 0, and that's why we don't take it.
Okay.
Yes, anytime, it is not actually in this only. Anytime when you differentiate a constant that does not have an x attached to it, that constant becomes 0. So, let us try this second
Excuse
function.
me, Mr. Makori, I have a question.
Yes, Nancy?
I don't understand this part. This
You don't?
dy, I don't understand this second part of the equation. This dy squared over d2x, the bottom one. Please explain that one.
Oh, you don't understand how we come up with this.
Yes.
Okay, let me explain. Where we are getting this from, we are getting it from the first derivative. You see, after differentiating this, we got this function. Now you differentiate this function to get this. That's why 3 times negative 24 is a negative 72. And then the power will reduce by 1 to be 2. 2 times 24 is 48. X raised to power 2, 2 minus 1 is x raised to power 1. So the second, the dy squared over d squared x is obtained by differentiating whatever you got after getting the first derivative. So it is a function of the first derivative. So you differentiate to get this first derivative, you differentiate this first derivative to get the second derivative. Are you okay, Nancy?
Yes, thank you.
Yes, that's what we are saying. So let us do this so that you can understand better. So whenever you are going to determine the second derivative of this function, first of all, you must get the first derivative, which is dy over dx, which will be equal to 4 times 9, which is 36. X power 4 now it will be power 3 plus 3 times 3, 9, x 3 minus 1 is 2 minus 2 times 8, 16, x raised to power 1. Remember now, this one there is power 1 there. 1 times 14 will be 14. And now, remember it was power 1, 1 minus 1 is 0. So x raised to power 0 is just 1. 1 times 14 is 14. So we are not going to have 14x anymore. X will disappear because that power 1 will minus another 1 because the rule of differentiation requires us every power we must reduce it by 1. So if we reduce this one by 1, it becomes 0. X raised to power 0, I say it is 1. 1 times 14, we shall just have it 14. Then when we differentiate negative 6, the answer is 0. Why is it 0? Because of the reason I gave. Whenever there is no x given, you just know that there is x power 0 that is silent there. So this 0 times 6, everything is 0. So we stop here. If you differentiate a constant, any number that does not have an x or an unknown, you differentiate it, it disappears. So we shall going to stop there. That is our dy over dx. Then to get now dy squared over d squared x, we differentiate the first derivative. So we are going to have 3 times 36. 3 times 36, that is going to be what? That is 19 plus 18, 108. X power 2. We just differentiate 3 times this one is 108. 3 minus 1 is 2. Plus 2 times 9, which is 18. X. Remember here there is 1. 1 times 16 becomes negative 16. The same logic. When we have 14, there was the 14 power, x power 2, and actually we got it from here because we had 14x. 1 minus 1 became x raised to power 0. This 0 times 14 makes everything to be 0. And this is now our second derivative. That is our second derivative. That. Are you now okay with getting the second derivative?
Yes.
Okay. So don't be worried. The second derivative is obtained by differentiating the function twice. You differentiate it once, you get the first derivative, which is dy over dx. The dy over dx that you got, you differentiate it again to get the second derivative, which is that. So that is it. After doing that, now we can go to another subheading on the same topic, which is known as the turning points. Turning points. So you can just indicate there turning points. You note that they are also known as the stationary points. They are also known as the stationary points. Also known as the stationary points. they are considered as the maximum. They are considered as the maximum and the maxima and minima points. They are considered the maxima and the minima points. Then you say that a maxima point is the highest point a curve will go. A maxima point is the highest point a curve will go before it turns downwards. It is the highest point a curve will go before it turns downwards. Highest point a curve will go before it turns downwards. It is represented as follows. It is represented as follows. So that point there is what we call the maximum. This is the maximum point. It is the highest point the curve will go. It will go up, up, up. It reaches that point, and now it starts turning downwards. That is the maximum point. Then you say on another line that a minimum point is the lowest point a curve will go. A minimum point is the lowest point a curve will go. Is the lowest point a curve will go before it turns upwards. It is the lowest point a curve will go before it turns upwards. The lowest point a curve will go before it turns upwards. It is represented as follows. It is represented as follows. So this lowest point is what we call the minimum. That is what we call the minimum. It is the lowest. The curve will go downwards, downwards, downwards. It will reach that minimum point, then it goes upwards. Goes upwards. Then say this. The maxima and the minimum points, into bracket, turning points, the maxima and the minimum points, bracket, their turning points, have a characteristic. They have a characteristic that the gradient at those points, they have a characteristic that the gradient at those points is always equal to 0. The gradient at those points is always equal to 0. The gradient at those points is always equal to 0. i.e. dy over dx at those points is 0. dy over dx at those points is 0. Remember the dy over dx that we are getting here. We said they are derivatives. They are also the gradient functions. So I want you to understand this. The calculus, it is normally applicable on functions. And these functions are what we normally call the exponential. And actually an exponential curve, it is actually a curve with a function in the form of y is equal to ax to the power 3 plus bx plus bx squared plus cx maybe plus d. Yeah? Whenever there is power 3 power 2 by that, whatever it is going to be, if we draw this one on a graph, actually it is going to give us a curve. It cannot give us a straight line. It is going to give us a curve because of these powers. It is not the same as when we have an equation like y is equal to 2x minus 5. An equation of this nature, y is equal to 2x minus 5, this is a straight line equation. This is a straight line equation. If you know it, this equation or the curve is going to be straight. But whenever we have power 2 or power 3, power 4 and all that, we are going to have a curve, and those are what we call the exponential. Things to note here is when it is a straight line, when it forms a straight line or a line that you can draw using the ruler, the gradient of that line is normally uniform. If you draw a line with a straight ruler like that, you'll find that the gradient, which is the same as the slopeness of that line, is the same. If you calculate the gradient here, any point on the curve, you'll find that that gradient or the answers are all going to be the same. Because if it is a straight line, the way this point is sloping is the same as this. But for the curve, the gradient at different points is actually different. The gradient at any point, the way this point has slanted is not the same way this point has slanted. It's not the same way this point has slanted. The gradient keeps on changing from one point to the other. And therefore, whatever we get when we differentiate this, it is actually known as the gradient function. I want you to consider this example. This is just for your understanding. It's just for your understanding, so that when we say that the gradient is always equal to 0, you should understand the concept. If you have a curve with the equation y is equal to 2x squared, this is y is equal to 2x squared minus 12. Minus 12x plus 9 minus 9. So, one thing you need to know that when this is drawn on a graph paper, when it is drawn on a graph paper, it is going to give us a curve like that. It is going to give us a quadratic curve, which we call a parabola like that. Now, because the gradient is different at any given point on that particular curve, when we do dy over dx of these functions, we are going to get it as 4x minus 12. That is the gradient function, because that one will be 0, this one will be like that. So, this is the gradient function. And being the gradient function, this is the gradient function, and being the gradient function we need, it can be used in determining the gradient at any given point. So if we have this one on our x and y, if this curve is drawn on the x and y, and maybe we have the point where x is 0, 1, 2, 1, 2, 3, maybe 4, like that. You can be asked, determine the gradient of this particular curve when x is 1. When x is 1, remember, let me adjust it. Remember, our dy over dx, we are found it to be 4x minus 12, which is actually the gradient function. So when x is 1, because we are told to determine the gradient of this curve when x is 1, maybe it is somewhere there. The gradient will be given by, we substitute here by 1. We are going to get 4 times 1 minus 12. So the gradient will be 4 minus 12. The gradient will be negative 8. You just substitute the value of x in the gradient function to get the gradient at that point. So the slopeness is negative 8. So if we want to get the gradient of this curve when x is 4, so when x is 4, the curve is at that point. We want to know the gradient of this curve at that particular point. We shall go back to our gradient function, which is 4x minus 12. Then we now get when x is equal to 4, so we substitute 4 here. The gradient will be equal to 4 times 4, 4x, which is now 4 times 4, minus 12, which is the same as 16 minus 12, which is actually what? 4. The gradient is 4. So whatever we get when we do dy over dx, the equation is always considered as the gradient function. And one funny thing about now this point we are calling the maximum and the minimum points, which are actually the turning points, is that when we calculate the gradient is always going to be 0. If we come here, if we are aware of the value of x here, if we are aware of the value of x here, we substitute it in the gradient function. This gradient is supposed to be 0. Where the curve is turning, the gradient is normally equal to 0. And actually, this concept we are going to apply it now from this particular point up to the end of this chapter, because we shall be talking about the maximum profit or the minimum cost, the maximum revenue, and all that. Because the maximum profit is going to be earned, the maximum profit is going to be earned at the maximum turning point. The maximum turning point, it is going to be earned where the curve is at the maximum. So the gradient function of the profit or the gradient of the profit function at that maximum point will be 0, and then we shall solve that to get the number of units an organization should produce and sell for the profit to be maximum. But don't be troubled with all these calculations that are done here to demonstrate that. What I want you to take home and always remember is that at the turning points, the gradient is always 0. So at either the maximum point or the minimum point, the gradient is always equal to 0. And when we do dy over dx, dy over dx is the gradient function. And the gradient function is the function that we normally use to determine the gradient of the curve at any given point. If we want to know the gradient of the curve when x is 0, we just substitute 0 where we have x of the gradient function to be able to solve the gradient at that particular point. That is what I wanted you to consume. Having now noted that, we can go to the second type of calculus, which is integration. We can talk about integration for the next 10 minutes. We can talk about the integration of functions. You can write this and say that integration is the opposite of differentiation. Integration is the opposite of differentiation. It's the opposite of differentiation. It involves determining the total function. It involves determining the total function when given, determining the total function when given, the rate of change function when given the rate of change function, or derivative, getting the total function when given the rate of change function or derivative. It is normally obtained by the following general rule. It is obtained by the following general rule. If you are told to differentiate, it is actually going to involve a sign like that. It is like S, but it is an elongated S. You differentiate maybe, what can I say, two, let me put initials here first of all. Differentiate x power n with respect to x. You just differentiate that, differentiate x power n with respect to x. Whatever you will get now is going to be y is equals to, y is equals to, it is x power n plus 1 over n plus 1. We are going to get it like that. Remember, why are we adding plus 1? We have said that integration is the opposite of differentiation. When we do differentiation, when we are getting the dy over dx, we normally minus 1. Now that we normally minus 1, if we want to go back to where we were, then we must add that 1. We add the one that we had subtracted from that particular constant, so that now we can get the original value that was there. So, if you are given, if you are going to differentiate, maybe it is 3x squared plus 4x minus 6. You are told to integrate that. What you will get now, it is y. So whatever you have here is dy over dx. What you need now is to get your initial y is equals to. This is what will happen. You just add 1 to the power. You add 1 to the power, and whatever you get, you divide by the same. So we are going to have 3x power 2. The power we add 1, so it becomes 2 power 1, and then we divide by the same 2 power 1. Sorry, 2 plus 1. Plus 4x. Remember, I told you when there is no power indicated on this x, it is 1. When the power is not indicated, just know it is x power 1. Then you add 1 so that you get 1 plus 1, and then you divide by the same 1 plus 1. Minus 6. Remember, I told you whenever there is a constant, there is x power 0 that is not indicated there. So it is going to be 6x power 0 plus 1 over 0 plus 1. And then we normally add plus c, because there must be a constant that was differentiated to be 0. Yeah? And that constant, because it was differentiated to be 0, it is not here. We normally add that c to stand for it. To stand for it. So that now you can solve it to have this as y is equals to, so this one will be 3x power 3 over 3 plus 4x power 2 over 2. I'm just adding this minus 6x power 1 over 1 plus c. So that 3 and 3 will cancel. You find y is equals to x. Just a minute. So that you find that y, 3 and 3 will cancel, which are made x power 3 plus 2 will go to 4 2 times, so we can have 2x squared minus 6x plus c. So basically, when you are integrating, we normally add plus 1, and the answer we shall get for that particular power, we divide by the same. This one is the same as here. Here, you just go on like that. And when you integrate, you go back to the equation that was the original. So if you differentiate this, if you differentiate this function, if you differentiate that function, you shall get that. If you do dy over the x on this, it's going to give you exactly that. Because 3 times 1 is 3, and then you minus the power to 2, sorry, x power 2. This times this one is going to be 4. The power will minus 1, minus 1, you get this. Minus, this was 1 times this one is going to be minus 6. Like that. You find that you are coming back here. You integrate, you go back to the initial. So that was just an example. I want us to use a function that we differentiated to see whether we shall get the initial equation. But the idea is just adding 1 to the power and then you divide by the resulting answer. So let me adjust my camera. This. So I'm interested on this. We differentiated this function to get this. So if we integrate this, we should get the original one. So it is like now you are told integrate. Integrate, that is 6x power 3 plus 9x power 2 minus 16x plus 14. If you are told to integrate that, you simply do this. Whatever you are going to get is y is equals to add 1 to the powers. Add 1 to the powers and you divide by what you get after adding 1. So this one is going to be 36x power 3 plus 1 is 4, and then you divide by the same 4. Plus 9x 2 plus 1 is 3, then you divide by 3. Minus 16, remember here there is power 1. 1 plus 1 is going to be x power 2 divided by 2. Plus, remember I told you here there is x power 0. 0 plus 1 is 1, so it's going to be 14x power 1 over 1. Then you add plus c to stand in for any constant that might have been differentiated to be 0. So that 4 will go to 36 how many times? 9. So you find y equals to 9, x power 4. 3 goes to 9 twice. That is now plus 2x. Not twice, but right. So it's going to be 3x power 3 minus this one goes there 8 times. So we're going to have 8x power 2 plus 14x plus c. You realize that we have gone back here, and this c, it is now representing the 6. Remember when we differentiated 6, it became 0, but now because we don't know whether it was 6 or it was 8 or it was 10, we normally say plus c. Plus c. As simple as that. You just add 1 to the power. Whatever you get as the resulting power, you divide by the same value. You move on like that. So there is this example that we also want out. This one there was somewhere. Now you are told you integrate this. I want us to integrate this because this one was obtained after differentiating this. We differentiated this to get this. So if we integrate this, we need to get the same original equation. So if you are told integrate negative 24x power 3 minus 24x power 2 plus 18x plus 5. You are told you integrate that. So whatever you get after integrating is y is equal to negative 24x power 3 plus 1 is 4 divided by 4 minus 24 x raised to power 2 plus 1 is 3, then you divide by 3 plus there is power 1 there, and remember there is power 0 there. So 18 x power 2 over 2, that is 1 plus 1 is 2, plus 5 x 0 plus 1 is 1 over 1, and then we say plus C. So that at the end of the day, you find that y is equal to what? That one will cancel to be negative 6 x power 4. This one will cancel this one to be 8, so it's going to be minus 8 x power 8 plus this one will be 9x squared plus 5x plus 6. That is your original equation, and actually you can see it is like that. Only that this 5, because we differentiated this 5 to be 0, here it is going to be represented as 6. Any question? Are you okay with the differentiation? Okay. If everybody is at silent, then it means at personal level you are okay. Having done that, now the remaining part of this topic is to apply calculus in business. Application of calculus in business. You just have that subheading, application of calculus in business. Application of calculus in business. Application of calculus in business, that is a subheading. Then you record that any business is established, with a motive of generating profit. Any business is established with a motive of generating profit. And then you say that profit is a function. Profit is a function of total revenue, is a function of total revenue less total cost, is a function of total revenue less total cost. Total revenue less total cost. I.e., let us put it now in equations form. Want us to have some basics here. So profit, which is normally denoted by pi. So anywhere we shall be using pi, just know we are referring to profit, is given by the total revenue. It's total revenue you minus the total cost. Profit is given as total revenue, the total income that you have generated in your business, minus all the costs that you have incurred. The difference between the two gives you profit. The difference between the two gives you profit. So, in short, pi is given by total revenue minus total cost. Pi is given by TR minus TC. Then you say this total revenue. Total revenue or TR is given by price times quantity. The price times quantity. total revenue that you are going to earn in your business, it is the price. If, for example, I'm selling a particular item and those items are identical, the revenue that I'm going to raise in my business in a particular day or a period, it is the quantity that I'm going to sell because those items are identical. It is the quantity that I sold times the price of each item. So if I sold 100 items, each item is being sold at 100 shillings, then my revenue will be 100 shillings times 100 items. So I'm going to get 10,000. So I'm going to get 10,000 as my total revenue. And then also like there like an NP, price is the revenue generated from sale of a single unit. From sale of a single unit. Then you note that price is also considered as average revenue. Is also considered as average revenue. And therefore you can say that price or average revenue is given by the total revenue divided by the quantity. The total revenue divided by the quantity will give you the price. That is what we need to understand. On the same note, you can say this marginal revenue normally denoted as MR is the revenue. Is the revenue that is generated by producing and selling one additional unit. Producing and selling one additional unit. The marginal revenue. The revenue the business is going to get as a result of producing and selling one additional unit. If, for example, I was selling 100 units and earn a revenue of 10,000, I produce and sell one more, so I sell one instead of 100 units. I sell one, and maybe I get 10,090. 10,090. When I was selling 100 units, I was getting 10,000. But when I sell one, I now get 1090. The 1090 there, the 90 shillings on top is now what we call the marginal revenue. The additional revenue as a result of increasing the produce by one, the marginal revenue. Then this one on price cut to be under note 1. The marginal revenue to be note 2. This one to be note 2 on marginal revenue. Then you say still under marginal revenue. Then you say marginal revenue function. Marginal revenue function. Remember, a function is an equation. Is obtained by differentiating. Is obtained by differentiating total obtained by differentiating total revenue function. Is obtained by differentiating total revenue function. So MR is equal to change in total revenue over change in Q. Remember there we were saying dy over dx. In this case, because we shall be talking about total revenue is equal to something and the Q is the unit, it is the same as now. Instead of dy, we have TR, change in TR over change in Q. Like that. Want also to show something. We consider now the total cost, and we say here total cost is given by the fixed cost is given by the fixed cost plus variable cost. The fixed cost plus variable cost gives you the total cost. So when we talk about the business costs, some of the costs in the business are constant or they are fixed. And a good example there is the business rent. The business rent does not change. It is actually constant up to a certain level of output. It doesn't change. So those fixed costs, you add the variable costs. The variable costs are those that keep on changing depending on your level of production. If you produce more, those costs, they are also going to be more. If you produce less, they are also going to be less. So they normally change depending on your level of output. But for the fixed cost, whether you produce more or you produce less, the costs are constant. So the fixed cost plus both variable costs. The variable costs include things like the raw material cost. If you want to produce more, you are going to incur more in terms of raw materials. The labor cost, if you want to produce more, you will have to involve many people and you have to incur more on their salaries and wages and things like those. But for the fixed cost, where we have a good example as rent, they remain the same. The rent of the premises, whether you operate it 24/7 or you don't operate the whole month, the rent remains the same. So that is what you need to note. And then you write there that NB, the average cost. The average cost is the cost. It's the cost of one unit. It's the cost of one unit. This one is normally given as this here. It is the cost of one unit. If it is given as average cost is the same as the total cost divided by the quantity. It is given by the total cost. Remember the total cost we say is given by GC over the quantity. Then B, we can talk about the marginal cost. The marginal cost is the cost incurred, in producing and selling one additional. In producing and selling one additional unit. The cost incurred in producing and selling one additional unit. It's known as the marginal cost. Then you say that marginal cost, marginal cost, actually it's normally denoted as MC, is obtained. Marginal cost, let us say function. The function is derived by differentiating total cost function. It's derived by differentiating total cost function. But don't forget that differentiating is the opposite of integrating. So sometimes the question can give you the marginal cost function. If you are interested in the total cost function, if you are given the marginal, you integrate, because TC was differentiated to get MC. MC is going to be integrated to get TC. We shall see those application questions. And for today, I want us to stop there. Then when we meet next week, we shall just go straight to those application questions. We solve them, and I know now you will be sorted. We solve them, and you will be sorted by that. Otherwise, if there is no question, we can end the class there. Any question? Okay, if there is none, let us stop there. And I wish you a blessed weekend. We shall meet next weekend. Thank you very much for coming.
Thank you.
Thank you.